Welcome to our first statistics video, section 1.1, what are data? Okay, so the study of statistics rests on two major concepts. So we've got the concept of variation and of data. So let's define those two big key words that we're going to use throughout the semester. I think we all know what variation is in quite like the layman's terms of it. So it's just different or distinct forms or versions of something that's slightly different from another of the same type. So we're specifically going to be looking at variation in the context of data. Data are the observations that you or someone else records, numbers that have a context to them. Okay, so we're going to be looking at how do these numbers vary. And that put together is what data analysis is. That we are going to look at data, we're going to look at the variation between the different data values that we have, and we're going to create summaries to explain what they tell us about the real world. Okay, so here's an example. It says draw 3 circles here. So humor me and try to draw 3 circles. If you're anything like me, your 3 circles are not going to be exactly the same. So most likely there's slight variations of round. My first one does not look very round, but it's a variation, I suppose, of round. How could we reduce the variation that occurs in an example like this? Well, I would pull from some of my geometry knowledge, which is there are some tools I could use here. I could use a compass or maybe a protractor. Those are tools that I could use to create circles that are exactly the same. I could also be a little bit less formal about it. Maybe I could just find something to trace, like a quarter maybe. And something that a student told me one time was maybe use a copy machine. I could draw one circle and then I could just copy it as many times as I want. So I could really get into creative to try to decrease the amount of variation that was occurring in my data. So the drawings themselves are data, but analyzing a drawing is kind of difficult. So what we would try to do is we would try to give some numerical value to these images. So what numerical values can you record about circles in order to analyze them? Again, kind of thinking back to geometry days, numbers that are associated with circles could be the areas of the circles, maybe diameter, or radius, or radii, right? The diameter is how far all the way across are they, and the radius is just halfway. So we could compare those values together. Maybe the circumference. And those are the big ones. So we could use those and we could talk about how do their circumferences differ and how do their areas differ and things like that. So what we've got in number 2 is we have a list of numbers, and that is exactly what it is. Right now it's just a list of numbers. If we want to turn this into data, if we remember from our definition above, what is data? Well, data is not just a number, but it's a number with context. So that context is what's missing right now. So I need to give these numbers some sort of context in order to truly call them data. So I'm just going to give an imaginary context to this. Perhaps these are ages of students in a statistics class. Now they have context, and now I can call them data. Now if I were to analyze them, there would be a meaningful conclusion that I could come to about them. If I were to maybe find the average or find the mode or all of these different values that we will talk about a little bit later, then there would be a context. It would mean something to me. Okay, for our last example, we are going to look at what would happen if you went to perhaps Subway, you grabbed 5 bags of potato chips from the end of the line there, and they're all marked that they're 1 ounce bags. But when you weigh them, you actually get 0.92 ounces, 1.01 ounces, 1 ounce, 0.99 ounces, and 1.015 ounces. Well, the numerical recordings, so those numbers are your data. Right, those are the numbers. They have context. We know exactly what they mean. And the difference among these measurements is an example of variation. So as we move through the semester, what we're going to realize is some variation is to be expected. I cannot reasonably expect that every single chip bag will have exactly on the dot 1 ounce in it. Some will be slightly heavier, some will be slightly lighter, and it's due to the machines or maybe a human who's running the machines. And that doesn't mean that it's false advertising or anything like that. Like we expect a small amount of variation. But when there gets to be more than the small amount, like there's a threshold, and if the data vary more than a certain amount, then we might start to second guess, maybe these aren't really 1 ounce bags. Maybe the machine is calibrated incorrectly, and maybe we should investigate that further. So those are the kind of things we're going to dive into throughout the semester. So why is statistics important? Well, mostly because data is all around you, more and more every single day. Everything in your lives are associated with data in some way. So think about how your phone and your tablets are using data about what you search for. They maybe collect even data about where you are, your location, in order to market things toward you better or to help you perform certain tasks and things like that. So as technology just becomes more prevalent in our daily lives, data is going to be more and more important for everyone to understand, not just mathematicians. So that's why this course is becoming so popular. I will see you in our next video for more statistics.